we redesign the innovation pathway for personalized therapies so that even for those with rare diseases, even for those for whom standard treatments don't work well, how can everyone have access to the therapy that's just right for them?
The ultimate conversation that we're having here, it's not about technology, it's about values.
Access to your own genomic data should be a fundamental human right.
Hello and welcome to this live episode of the Doha Debates Podcast at the Precision Medicine and the Future of Genomics Summit in Doha, Qatar. So today's conversation is presented in partnership with Sidra Medicine. Today, we'll be asking our guests, can precision medicine and genomics create a fairer future? So we'll examine how this vision can be achieved, delving into the ethical challenges as well as the practical realities. Our aim today is not to argue, but to contribute to the collective wisdom that's necessary to guide humanity towards a place where these advances are used for the greater good. So I'm pleased to say we're joined by Sarah Chan, who's a bioethicist at the University of Edinburgh, Arash Rafii, a gynecologist, oncologist, and geneticist, and right here with us, Jamie Metzl is a technology and healthcare futurist. Please join me in welcoming them. Okay, first, let's set the scene a little bit. So, we can define precision medicine as medical care tailored to individuals by using genetic or molecular profiling, and genomics as the study, mapping, and editing of human genes. These advances represent a huge range of potential benefits for humanity and significant risks as well. So today, we'll try to identify the issues that will most influence the creation of a fair future for everyone. So what has you excited and maybe a little bit scared? Sarah Chan, I'll give you around 2 minutes for your opening statements.
Thanks very much. So we're at a point of realization, a point of fruition and acceleration of these technologies where what's developed for whom and for how are going to shape what healthcare looks like in the future. Now, we often think of justice and fairness in terms of the end products of medical research. You know, we've developed this therapy, who's going to be able to afford to access it? But what I'm going to suggest to you today is that genomic justice, as I'm calling it, has to start way, way back, right at the beginning of the research and innovation process. It has to start now for the fairer future. And I'm going to just lay out a few examples that I think highlight some key challenges that genomic justice needs to face. Let's take precision medicine itself to start off with. So this relies on health and genomic data from many to make predictions and target treatments for each individual. And the more people who are in, the more data we have, the better these predictions are. But the flip side of that is that if only certain kinds of people are included in our data, the predictions that are made will be more accurate, the treatments will be more effective for only those sorts of people and not others. So the first key challenge is making sure that precision medicine is genuinely about and for all of us. Access to participation in data research at the stage of collecting the data, even before what we do with it, is key for genomic justice. My second example is genome editing. What do we research and what do we design treatments for? Now, we've just heard some people give their views about fairness and gene editing, and a common argument is, well, it's going to make inequalities worse because only some will have access and others will be left behind. We have this world of the gen rich and the gen poor, or genetic underclass, if you like. But first of all, this doesn't have to be the case. The visions of genetic dystopia aren't inevitable. How we develop and regulate the provision of these technologies will determine whether they increase inequalities. But why stop there? We already live in an unequal world. Why stop at let's not make inequality worse? What we should be asking is how can we use genome editing to make things better? Which diseases can we target that are going to make those who are now worse off better off in the world? And so the second key challenge is that our conception of genomic justice has to include active, not just passive justice. How can we make things better? And the third, which I'm just going to hint at, because I know my time is short, is ethics by regulatory design. How do we redesign the innovation pathway for personalized therapies so that even for those with rare diseases, even for those for whom standard treatments don't work well, how can everyone have access to the therapy that's just right for them? And I think we need regulatory redesign, and maybe we can open that up in the discussion.
Okay, we certainly will. Thank you so much, Sarah Chan. Thank you. Jamie, what about you?
Yeah,
what has you excited or maybe a little bit scared?
So, although the word debate is in Doha Debates, let me start by saying I agree with 100% of everything that Sarah just said. But let me take a step back and try to position ourselves. It's like when you see a picture of the Milky Way galaxy with that little arrow and it says, "You are here." So where are we now in the history of human habitation and life on Earth? And the big story of this moment, with huge implications for human health and all of life on Earth, frankly, is that at this moment, after nearly 4 billion years of evolution, our one species has the increasing ability to engineer novel intelligence and re-engineer life. It's a fundamental change in the way that life has been organized on this planet, and we're at the very, very beginnings of that. And it's going to have huge implications for many, many different things. And within that context, one of the actually smaller stories, but a very important one for us, is what is this going to do for human health and human health care? And we've heard in this conference a lot of pieces of this story, but the macro story of the transition in our healthcare system is that we're moving from our current world of generalized healthcare based on population averages. If I were to get sick here in Qatar and go to any of your health facilities here, I would have complete confidence that I would be treated based on the highest standards, because we've distributed this system of generalized healthcare based on population averages, where all of us are treated based on the similarities, in most cases, between us as humans. We're moving, as is the subject of this conference, to our world of precision, personalized or precision healthcare, where we're going to be treated increasingly based on our peculiarities as individuals. And as part of that, and we've heard about these different treatments, whether it's stem cell treatments or pharmacogenomics, gene therapies, lots of other things. But as our gateway into that world, we're just going to need to collect a lot more data, as Sarah just mentioned, because if you only have information and data, genetics, and multi-omic information about one person, it's useless. It's only valuable in the context of these massive data sets. But as we develop these larger data sets, that's going to allow us to transition to our next phase of our transformation in our healthcare systems. I said generalized to precision, and then it's precision to predictive and preventive, because when we have these massive data sets, we're going to realize that we all live within a range of biological possibility, and the ultimate goal of healthcare, and maybe life, is to kind of optimize at the upper end of our individual possibility, and then to say, are there areas where we can go beyond that, like vaccination or lots of other things that we currently do, but the range of possibilities to do all of those things will increase. The good news that I'm excited about is this opens up all new kinds of really wonderful opportunities. We can cure and prevent and treat all kinds of deadly diseases. We can live longer, healthier, more robust lives. We can have greater agricultural productivity and all sorts of things. And it's really easy to imagine those utopian scenarios. And as Sarah just mentioned, it's equally easy to imagine all kind of dystopian scenarios where these technologies are used to undermine our humanity, to make our societies less equal, to divide us from each other. And the key issue is that neither, as Sarah just said, neither of these futures are inevitable. There is no built-in value system that comes with these technologies and capabilities. It's up to us to infuse our greatest values into how these technologies and capabilities are realized. And so that's why the ultimate conversation that we're having here, it's not about technology, it's about values.
Okay, we're going to come back to a lot of these points. Arash?
Thank you, guys. I mean, it's been very inspiring already. And I want to start by a question. How many people in the audience have their genome or any knowledge of their genome? Okay, so, I did my genome personally. I like to bring it a little bit more personal and to because we're talking about fairness. So I did my genome for a lecture for students. I thought it was more engaging to present something, and so I did my genome very early on when the technology started in 2008 or 9. And the main trait that I had was that I'm at risk of hypertension, so which I had no clue, and that I have a tendency to be right. So that's for the sake of the debate. I don't know how true that part is. And then, so I started acting on that. So it's knowledge, and I start compounding on that knowledge, exactly like we're in a capitalistic society, basically. All the models in the world are capitalistic, and now work is not as valued as capital, and capital creates benefits. And so I start compounding on that, change my diet, surveyed my hypertension, etc. And for the next 2 to 3 years, my wife begged me to do her genome, which I kind of didn't do out of laziness, forgot to bring the tube, got the tube, lost it, etc. And 3 years later, I finally did my wife's genome, and she has a way more serious genetic defect that puts her at risk of cancer, and so she would need to have like a specific like follow-up and specific surgeries. So basically, now she can compound on it. And now, in our couple, which is like 2 individuals, our relationship is more fair. For 3 years, I was able to get knowledge of myself, and then, and she was not able to have that. And so I want to argue that there's no difference between genomic data and the ability of look at yourself in the mirror in the morning. Nobody prevents you from that. But today, genomic data, because of some kind of unjustified created fear by establishment regulators, seems to be the dark thing that insurance will use, employer will use. Oh, I put my genome on LinkedIn this morning, so you can go and download my germline variants. It's accessible to all. It's an open source platform. You can download it, and if you find something interesting, please revert back to me. So I want to show privacy is not the issue. The lack of knowledge is really the issue of the question. So I want to argue today and kind of discuss with you guys that access to your own genomic data should be a fundamental human right. And as a fundamental human right, healthcare organization, government should fight to get the access to everyone. The price and the cost is not a problem anymore. It's less than a CT scan or an MRI. So I would like to hear your opinion about that statement.
Okay, let me just jump in first before that. So a lot of points highlighted by all of you. With these opening statements, let's dig in a little bit deeper into the potential benefits and risks. So feel free to respond to what the other person has had to say, but Sarah, I'll start with you. I mean, you spoke about genomic justice, and you also spoke about the importance of fairness. But what does that fairness actually mean practically in the context of precision medicine and genomics? And should fairness then provide those who are worse off, or prioritize, those who are worse off, or should it focus on providing equal opportunities for everyone?
So, as I said, we already live in an unequal world, and genetics up till very recently has been a matter of luck. So whether you have good luck or bad luck, whether you have good genetic luck or bad genetic luck, that's been something that's out of our control. So this conception of genomic justice, now that we start to be able to understand the genome, we can read the genome, can we rewrite the genome in such a way that, those who have bad genetic luck, those who have genetic diseases that hamper their life, can we do something about that to try and compensate them for that? And so the idea of genomic justice is that we are trying to make these inequalities, we're trying to make them better. Let me expand on this idea about genomic justice in the context of regulatory control of new therapies, right? So we know the cost, for example, of developing a new therapy. There's how research gets done, there's what gets researched, and then there's how do these new treatments get from the lab to the clinic to the marketplace. And so this whole process of clinical research, approvals, licensing, purchasing into healthcare systems, this is a long process. And the translational pathway at the moment is designed around and it's optimized for the era of medicines that we had, but it's not optimized for the genomic and the genetic era. So, when you have one size fits most therapies, it's what Jamie was talking about, based on our similarities. What comes out of the box is the same every time, and then it works reasonably well for most people. But genomic medicine takes that and flips that on its head. Personalized medicine, cell and gene therapies promise to change that. So what's in the box might be different every time. It might be your own cells or a gene therapy that's been tailored to your genetic profile, but it's personalized to you. And so again, we have this problem of inclusion because the effectiveness of genomically tailored treatments is going to depend on how well we understand your genome and the genomes of people like you. I like this idea about access to genomic information being a human right because it's going to be so fundamental to the healthcare that we receive in future. But there's also, I think, an opportunity here. I talked about regulatory redesign. Could we think about the process so that no matter how rare your mutation is, no matter how unusual your genetic profile is, producing a treatment for you would be as streamlined and simple as opening a box of pills? And how are we going to get to that point?
Okay, Jamie, go ahead.
Yeah, so I certainly believe in an abstract way with genomic justice, and the issue is just the specifics of how we do it. I was a member of the World Health Organization Expert Advisory Committee on Human Genome Editing, which was created in the aftermath of the birth of the first two and then the third CRISPR babies, genome-edited babies that were born in China. And so on one hand, there was a justice issue there, and I certainly was then of the belief, and am now of the belief, that was a highly unethical intervention. But I do think that we are in the future, and certainly not safe or ethical now, but at some point in the future, I believe that our species will become a genome-edited species. Not everybody, but increasingly more of us. And the reason is we already live in a world where we think it's appropriate. If a child is born with a potentially deadly genetic disorder, we will do everything possible to save that child's life. And so we're going increasingly, as I think Sarah at least referenced, live in a world where there'll be different interventions that we can do at different times of a person's healthcare journey. It may be that right now what we call healthcare, it's really symptoms-based sick care. That somebody shows up and they have a symptom, maybe that symptom has germinated for whatever their age is, plus 9 months, and we treat it that way. We can do treatments now, fetal surgeries, which are now increasingly common. And there will be a relatively small number of genetic disorders which we can actually treat and prevent at the pre-implanted embryo stage or even at the sperm and egg stage. And the question is just going to be, for us, is how do we think about what intervention personalized at the right time? And all of this is going to happen in a context. So, and coming to Arash's point, yes, I mean, I'm a big data person. There's no amount of data information about myself that I don't want, and I would encourage everybody to be the same. But we live in societies that have governance systems, that have regulatory systems that protect us. And so I don't think we should be protected from just information. I think a lot of people in the healthcare system are worried if people get too much information, they're going to be demanding tests and surgeries that they likely will not need. But we do need to think about the superstructures of governance and regulation that can protect people.
I want to reflect
Arash,
on
go
two
ahead.
things. I think genomic justice could be even put under an umbrella of medical justice. And I did a lot of NGO work, and you go from France, where a woman who had mastectomy can get the most complex reconstruction for a cost of $100,000, and you go the next day to Lebanon when a woman cannot get chemotherapy. And so globally, right now, at the scale of the world, I think the level of injustice in medicine is extremely high. It's probably way higher than like justice in educational system, because like 80% of now kids go to at least primary school and the beginning of high school. I think vaccination is like completely like almost everywhere available for kids, but medical care is extremely not equally distributed across the world. So I think that the first problem is, do we want to tackle that? You know, I did medical school in France. Nobody talks to you about these global issues of, oh, if you go to Africa, you cannot get a simple chemotherapy, and people die of breast cancer at 40 years old. Nobody dies of breast cancer in France. So that's the first thing that I want to really kind of put on the table, is that we should have a global view of, you know, like Doha is at the top, France is at the top, US is probably at the top of medicine, but then the other countries are really left behind modern medicine because modern medicine is somehow extremely costly by default of the level of technology. The second point is I'm always extremely careful with who owns the power to regulate, because the interest is not the same. I do think that every woman should get BRCA testing because that avoids a certain cancer. And it's forbidden in France by law, and it's forbidden in France. And you look at the structure of that, it's basically some geneticists are using the fear of knowledge. Basically, if a woman knows, she's going to be scared and anxious, etc. And so they should not know. That's the first thing they use. The second argument that a lot of geneticists will use is people will not understand. So that's very, deceptive of people. People understand. We can educate people. Everybody in the street knows cholesterol is bad.
Right.
They don't understand the biology of cholesterol, but they kind of understand how it works. And people have no problem dosing their cholesterol. But when you do a blood test for your cholesterol, what you're actually looking at is how your gene regulates cholesterol. So it's a proxy for genomic information. And nobody wants to forbid that. If we go in a country and I say, oh, people should not know their cholesterol, you would say this guy's insane. So genomic has created suddenly a whole fear. And the fear comes from insurance issues, and the fear comes from people thinking that if you know my genome, you're going to know me better and read me better. But that's actually good. I would love to know myself and my kids better. And one example, one thought experiment that I use is there's genes for addiction and are known. Some of the genes associated to schizophrenia are known. And imagine you know that information at birth for your child, because I would defend that every child should get sequenced. Then at 15, you can start, when they can get exposed to addictive substances, you can start having at least one clinic with a psychotherapist with them to talk about it and kind of do a more thorough follow-up for a kid that's at risk, and even adapt their educational system to their genomic background. My son has dyslexia. He's not adapted to the normal educational system. If I have a genomic test that says, oh, these kids need a different educational system, he can have a more fair approach to. He's been suffering for the last 18 years because that data is not there. If you now have a medical test that says this guy is at risk of that or this guy is at risk of that, I think you can get access to better lifestyle, not only healthcare.
Let me just jump in there for a moment, just to pick up on a point that you had earlier said, which I wanted to put to Jamie, because Jamie, you mentioned it as well. You were talking about the importance of collecting data. You were touching upon privacy as well. Are there any fears, Jamie, when it comes to collecting data and that kind of information could be used against people?
Absolutely. Like I said in my opening statement, none of these technologies have built-in value systems. And just all of data, not just medical data, health data, all of data can be used in ways that supports us and empowers us, and it can be used in ways that undermines and harasses. I completely agree that in the world that I think I'm imagining, maybe we're all imagining, everyone has their whole genome sequenced at birth, or soon after birth, or even before birth. And then we have some kind of risk characterization and stratification so that we have information that could be highly clinically relevant. If you have a genetic predisposition for type 2 diabetes, it really puts a lot of pressure to focus on issues of diet and lifestyle. Or if you're a woman with a genetic predisposition to a genetic form of breast cancer, it would make a lot of sense to start your screenings when you're 20 and not when you're 40. And all of this information is really important. And it's not just genetic information. I mean, we're entering into a new era of complex multi-omic systems biology. So it's not just genetics. And the more we learn, the more we realize how complex and dynamic these systems are. So we need these massive, very complex data sets. We need interoperability. The UK Biobank is kind of the gold standard for these big data sets, but we're sharing information. All of it is potentially great and potentially awful. And so that's why the name of the game is, how do we, driven by our values and inspired by our goals, how do we build the kind of superstructure that can help us use these incredible capabilities to enhance our lives. Because this isn't, it's not, the question is not how do we use these technologies. The question is, what are our goals and values and aspirations, and how do we build that kind of future using not just these technologies, but all the other even non-technological human systems, values, governance, regulation, norms, all of these things to try to lay the foundation
Sarah, but there
for that
has
future.
to be safety nets for technology, does there not? I mean, and where do you stand on this issue?
Okay, so I want to pick up on, you asked about the risks earlier, and just building on this idea about, imagine a world where every child has their genome sequenced at birth. What's that going to do for us? Going from that kind of idea to, well, what are the values in this new genomic society? I think we need to distinguish maybe, or to draw a difference perhaps between data and information. And there's a problem here, right, of interpretation, but also a risk of over-interpretation. What are we going to know about people from their genome? So our genomes determine a lot about us, but they're not all we are. And I think, we need to also guard against this kind of genetic or genomic essentialism, that once I know your genome, I know everything about you. What sorts of hidden values are we importing there? When we have a world where you can say, well, this child, when they grow up, is going to need to have a low-fat diet and do this, otherwise they're at risk of X, Y, and Z. What are we going to do with that information? Are we going to make recommendations, or are we going to say, you know what, you knew your genome, you did nothing about it, your bad health is your own personal lookout? Are we actually going to use that to shed responsibility from society to say, look, now you know your genome, you're on your own? So I think that's, that's one of the ways in which the values that we're importing in how we use this information could go either way. I think like insurance is another example. Is insurance there to try and create a fairer society, or is it there as a sort of gamble that you got the good genetic cards? Now I think it should be there to create a fairer society. But if we're going to say, look, once you know the cards, then you can't play anymore, sorry, your hand's bad, then we're not using it to improve fairness.
Yeah, and I think that the insurance point is really important, because that is a regulatory issue. I mean, let's just say hypothetically you were in some kind of society that had no governance, no regulation. Then you could just have the health insurance companies and get all of your information at birth and say, we're going to put you in a high-risk category and you're going to have to pay 10 times more premiums. And the entire point of insurance is that we're kind of sharing the risk across society. So I think we're going to have a lot more information about ourselves. Other people in these systems are going to have more information about us, and that's why everything comes back to values, and these values will not be realized on their own. I completely agree with what Sarah said. The values, it's not that we're going to do the research, you put these technologies in the world, and then have a few sociologists have a conversation about values. The values need to be articulated from the beginning and woven into every decision that are made at every level, and that will at least increase the odds that we can optimize benefits and minimize risks.
Arash, go ahead, and then Jamie, I do want you to clarify one thing, which is, one second, Arash, which is governance versus regulation, and if you can explain the difference in the conversations that need to be had at this point. But Arash, please go ahead.
Yeah, I want to reflect on two things. The first thing is that the insurance paradigm that everybody's using is I talked to insurance companies when I was starting the Genomic Foundation in France, and they actually don't want it, because most people would say, I'm not at risk, so I should pay less, because the insurance, we're paying the maximum risk. We're already paying, that's the way they do the math. They do the math that I might have a cancer, I might have a heart disease, and I might have a car accident today. If I tell them I'm not at risk of cancer, so like, the insurance are not really looking forward, increasing their premium, and they're afraid of decreasing it. And I think the other issue I want to reflect on is the term privacy. Privacy, I don't really understand the concept of it. It's like, I don't want people to know. I mean, most people show everything about their life on Instagram right now, so I think privacy has like plummeted down. It's like not existent anymore. But I think it became...
But you think medical privacy doesn't exist anymore?
No, I think privacy is the fact that I don't want other people to know. But unfortunately, not information and not data or intelligence, I would call it genomic intelligence, comes from a lot of people sharing. So you need thousands of people having their genome and kind of giving information on their life as they go, because the problem of probably the genetic analysis I did for me in 2009 or 10 is not valid anymore. And one of the reasons is privacy. I didn't share it, so other people don't know what are the risks. And I didn't update any real-life data. My body has changed, my abilities have changed over the last 20 years. Unless I give that information to a system, an AI-based system probably in the future, there's no way we can make prediction. The more we give information about ourselves, the more it can help me. So, for example, maybe tomorrow, my personalized genome interpretation is going to tell me, hey, Jamie has the same similar gene that you, and when he trains for a marathon, that's his achievement. If you train, you might optimize your training.
Right.
And that needs collective intelligence. And we have to understand that privacy is not sharing intelligence. Privacy is some stuff I don't want people to know about my life, and some stuff I would benefit from people to know.
Okay, Sarah wants a quick interjection, and then Jamie, over to you.
Look, I just want to say something about privacy, because I think you're right, it's a controverted concept, right? And I want to make 2 points. One is that it's relational. Privacy only makes sense when there's more than one person in the equation. And then it's not just about who has access to information, but it's what they do with it. How do you treat people on the basis of that information? So imagine this, right? My colleague comes into work, and her makeup's all running, she's obviously been crying, she's upset, and I say, hey, what's wrong? And she says, nothing, nothing. Now, I don't infringe her privacy by noticing she's upset. I infringe her privacy if I then go to her and I say, no, you've got to tell me, hey, everyone, look, she's really upset. What's happened? That's infringing privacy. I respect her privacy by taking her answer, I'm okay, at face value, and saying I'm not going to pry further. So similarly, how we treat people on the basis of the information we find out, that's where privacy lies. And the other important point, right, no data system is 100% secure. Anytime data exists, it's out there. Someone's going to have access. So if we're concerned about protecting privacy, we need to regulate what can be done with the information once it's out there.
So, fine, perfect. You've mentioned regulation. Jamie, this is
So,
where you come in. So explain the difference between governance and regulation.
A few quick points. That's a very British answer. Oh my God, you've been crying. I'm going to take a step back. America, it's like, come, let's hug it out, colleague. And then, again, the point that I made earlier about genetics and complexity, the more we learn, the more we are going to realize that humans are not just genomes walking around on stilts, that there's a complex systems biology. And so certainly we have genetic determinism for a relatively very small number of single gene traits and disorders. But for most of what we do, I think it's not going to be absolute determinism, but I think there will be directional information that will be more or less relevant in different contexts. And then there's a bit of a mismatch, because it's like fingerprint evidence in criminal trials, because people have so much trust in science. If someone says, I'm looking at your genetics, and you are destined to have X. I mean, if it's a single gene disorder, that maybe that's true, but in most cases there's a lot of complexity, and I think, and that comes back to the point that I was making earlier. We really need to think about the superstructure. And so governance and regulation, I mentioned I was a member of the WHO Expert Advisory Committee on Human Genome Editing, and in our report, it took 2 years to come up with our recommendations, and we made a very strong point of separating out governance and regulation. Governance is the big category. These are big systemic changes. They're civilizational changes, as I said in my opening remarks. And they are too big for governments alone to manage them. Government regulation is very important, but it's a piece of governance. Governance is what happens at every level. In the context of healthcare, it starts with individual empowerment, what happens in communities, in businesses, in healthcare systems, hospitals, countries, internationally, and globally. And because these changes are so profound, and as I said before, there's this broader change, macro change, which is showing up in healthcare, and that is the story of precision and predictive and ultimately predictive and preventive healthcare. We're going to need to think about it. I talked about values being woven in at every level.
Right.
In a society like Qatar or UAE, the governments have a relatively more important role, but even in a place like this, to manage these technologies and capabilities well, it's going to take everyone.
Okay, hang on one second, because we have some amazing students who are standing by for us, and they're ready with some questions, so we're going to hear from them now. First, we have Abrar, who's from Hamad bin Khalifa University studying genomics and precision medicine. Very fitting. Abrar.
Hello, everyone. Nice meeting you all. I forward my question to Dr. Metzl. You mentioned in your book, Hacking Darwin, that the bioethicist Julian argues that parents are obligated to create children with the best chance at fulfilling life. However, several ethical agencies recognize the moral status of embryos, which restrict the gene editing of newborns. So, do you see a way to honor both points of view?
Thank you so much, and it's a great question, and thank you for studying what you're studying. We're really counting on you. So I do think that those are compatible point of views, but not right now. Right now, as I said before, I don't think it is ethical in any way to edit the pre-implanted embryo of a human being and then to implant that embryo in a woman to take that to term. The science is not ready for it, and doing so is it's Nuremberg-style human experimentation, which I think should be roundly not just condemned, but absolutely vilified. But I also believe that, as I said before, that is not always going to be the case. And how X years from now, and X could be measured in decades, maybe small numbers of centuries, but X years from now, it's going to be very normal. And we have all of these kinds of things that seemed crazy. 46 years ago, the world's first IVF baby, Louise Brown, was born in the UK, and it was absolutely controversial. It was condemned by the Vatican and others, and now IVF is absolutely normal. And so it will be normal at some point in the future to genome edit pre-implanted human embryos in order to transition what would be a short a life followed by a painful death of a child that would be born with a genetic disorder to a 90 or 100-year fully realized life. But we're certainly not there yet. And we don't know what challenges our species is going to face in the future. And so part of the negative scenario planning is to say, well, let's just imagine we've just gone through COVID. We're entering the age of synthetic biology. Let's just say that there was some pathogen, maybe a symbiopathogen that was devastating, killing billions of humans. And let's just say that somebody said we can have a small genetic tweak in pre-implanted embryos to make future children who are immune to that absolute scourge. Or let's just say that this planet becomes largely unlivable. Or let's just say that we have humans who are going to live all of their lives in some kind of orbital environment in space. We can't do it with this biology that's been optimized for this very narrow band on the surface of this Earth.
Right.
So Julian's, who I was actually here with Doha Debates 4.5 years ago in this building, his view and that whole community's view is that we are going to then want to move into an area which is right now we would call enhancement. But it is at least my view that there is no clear boundary between therapeutic applications and what we call enhancement, because we live on a spectrum where there's a whole lot of gray area, and those hard lines will be impossible to protect. And so that's why I don't think that we're going to be able to say absolutely this or absolutely not. We're going to have to integrate our values into really tough balancing decisions, but we're going to need to have frameworks so we can make those decisions together.
We have another question
can
from...
Can I just reflect on that?
Yes, just briefly if you might.
I think that I want to bring the two concepts of governance and regulation. And I think I'm a gynecologist, so I see women every day in the clinic. And I think we don't realize they're the best governor of that. For women, having a child is extremely magic moment. Any woman that goes through IVF hates the process of it, thinking that most women are willing to go to have an IVF to just get a smaller kid is completely not understanding how a woman thinks. It's a very masculine way of thinking, oh, every woman here is super happy to have a kid with blue eyes, but they have to go IVF. It's going to be marginal. It's going to be extremely marginal because women don't have that. They want maternity. They want the love relationship. They want to give birth. And they're going to be the best regulators. They're just going to deny the product, and it's going to be a failed enterprise. The second thing, I think people confuse enhancement and consequences. And let's say I enhance my son for mathematical abilities, and then he wants to become a rap singer. He's just going to be miserable. You know, it's not because you're smarter at something that means that you want to do that thing, you know? And so there's no way today, I don't think, today we can't enhance anything or very marginally. And even if you give somebody more intelligence, you know, it can be have a miserable life because of like psychosis and things like that.
Thank you. Let me bring in our next student, Fatima from Qatar University College of Pharmacy. Fatima, what's your question?
Hi, my question is directed to Dr. Chan. Do you think that religious perspectives can play a role in regulations of genomic editing beyond ethics and moral principles? If so, what would this framework look like, giving in all these diverse perspectives and ideas of religious beliefs?
That is a great question. Thank you so much. I definitely think that regulation, and here we're talking about, you know, not just within countries, but also we're talking about this on a global scale. You know, what happens in Qatar, what happens in the UK, what happens in America. These are all going to be interlinked. So regulation needs to take account of diverse societal perspectives, and amongst those religious perspectives. That doesn't mean that we simply, you know, take what people think and say. You know, we heard in the opening video lots of diverse perspectives. You can't just take what people are saying and write that into regulation. So the relationship between policy making and engagement with publics is a complex one. There's multiple levels to it. We have seen in the UK, for example, you know, we've had multiple rounds of the first regulation around IVF. So the technology started in the 70s. We talked about it in the 80s. The regulation that governs this has been in place now for decades. But that's always having to be revised. So we've changed regulation in the UK a number of times to take account of technological advances. And what's really key is having that dialogue, that discourse with different publics about what the values are. But I think, you know, talking about diversity of values, that also highlights something around the way that we're going to use these technologies. So, you know, I'm completely in agreement, this vision that we're all going to want the same things out of genome editing. I don't think that's true. We value different things in life. We value being able to live our lives in diverse ways. So rather than this idea that we're going to produce an army of clones because we all want the same thing, the real challenge is going to be embracing the diversity, the different ways in which people are going to use this technology, and to say, you know, all these ways, all these different ways of flourishing, different accounts of the good life, experiments in living, as Mill would have it. All of these are valid.
All right, thank you so much. We have Mantala from Qatar University College of Medicine. Mantala, what's your question?
Thank you so much for the very thought-intriguing discussion. So my question is to Dr. Rafii. So as we know that big pharmaceutical companies pose huge challenges, especially for the underprivileged, so how do you envision that we can make gene sequencing accessible for everyone?
So I think gene sequencing is already accessible for everyone. I think like probably the price of it at like, if you just call any BGI or any company and you ask them for a price for 100 genome, it's gonna be under 300 to 500 euro, which is really not much as a healthcare expenses, you know, if you have a social security system. But if you call them and you say, we're 60 million French and we want to sequence all of them, the price is really going to drop. So it's a number of, like, the more you have, the more it's going to drop. And you have to realize, I really agree with Jamie that I think the whole, like, Moore's law is completely, like, ramping up. And so the prices are going to really plummet within the next 5 years. And not the price of doing the sequencing. It's not this, one is not important. The price of doing analysis. And so it's going to go faster and faster with AI. Probably most people will be able to analyze their data on their computer and ask a kind of LLM. You go on your chat genome or GPT genome and you just say, oh, am I at risk of, or should I train like this? And it will just know your genome and answer it. And that's also one of the reasons I don't really believe in gene editing, because technology is going to go faster, and it's going to be easier for you to have a neural link in your brain fully connected and be more smart and be able to draw and talk Mandarin in 1 minute than having your embryo modified for one of these particular characteristics. I think that's what we see, that we see is like you take obesity, for example. Obesity was a heavy treatment by surgery, and then one medication come out, semaglutide, and everybody's cured. So technology goes way faster than the biology manipulation. So I think it's already available to everyone. It's a matter of, I think, government, or as you said, or state to decide that it's cheaper for them to do preventive medicine than to wait for you to be sick to do that. And Jamie took the example of the BRCA patient as a woman. They should have, I had 28 years old woman with cancer, and they didn't know they were BRCA. At 28, it destroys your femininity, it destroys your family structure, and the cost of treatment is within hundreds of thousands of dollars of surgery and chemo. The same woman would have had the genetic testing, $300, and maybe just a surgery at 20 or 25 to get mastectomy. It's the best solution we have now. It would have costed way less to her personally, to her family, and then to society.
Okay. Yeah, and that's why systems reform and systems engineering is so important. I mean, we can just think of any intervention for really any disease, and we can come up with a suggested process that's better than what people are doing now. But there's a reason why we have all of these reforms, and at least in the United States, healthcare is just getting more and more expensive because we're just adding more and more things. So we really need to think systemically, and that is one of the opportunities in a place like here or in Qatar, or I mentioned UAE, or smaller places like Estonia. I can really figure out, and especially with relatively single-payer healthcare systems, can really figure out what's an optimal way to do healthcare, and versus the old model of ideas got imported from here to here from places that were more medically advanced in the Western and other parts of the world. Now there's a real opportunity for places like Qatar to export systems engineering models about how to do healthcare well in a preventative way that balances all of these equities, that incorporates all kinds of value systems, including critically important religious and traditional value systems. Because, like I said before, if the question that we ask ourselves is how do we use these technologies, we are going to get lost very, very quickly. The question is, what are we trying to achieve, and how can we best realize those goals?
Okay, which brings us to our final question from our student, Riham, who's an alumni from Qatar University who studied biomedical sciences. Riham, what's your question?
So, hello everyone. My question is for Dr. Chan. So basically, I want to ask how can we balance the benefits of early detection of genetic conditions with the ethical concerns about the child's right to autonomy and privacy?
Yeah. Good question. How do you balance that?
Really good question. I mean, let's reflect, right, on what we've been saying about privacy and autonomy, self-determination, self-knowledge. I would say, so privacy from yourself, I don't think makes sense. If you have access to your own genetic information, that's going to enhance your autonomy because it means you have some idea, assuming that you don't just have the data, but you have the information, you have the understanding. You're going to be able to make better decisions about your life knowing what's coming. You could decide to go for early screening because you know you have a predisposition to cancer. So actually, there are many ways in which genetic information facilitates the right to autonomy and the right to privacy. But I'm going to temper that by saying we need to make sure people not only have that data, they have the interpretation. I'm really worried about Genome GPT. ChatGPT gets so much wrong. I don't think that's going to give us information about our health. But we need to make sure that people have the resources, the scientific and the knowledge capital to be able to understand and interpret what they're being told about their genomes and what it means for their future. That's what autonomy requires.
Okay, would anyone like to comment on that? And also, let me throw a question in there. How can researchers sort of address the risk of genetic data exploitation while at the same time promoting advancements when it comes to population genomics. Arash, would you like to answer? And then Jamie, over to you.
Yeah, I fully agree about the privacy thing. I really think like the privacy thing is really, you should decide yourself. It's like, you should decide what you were doing. For data exploitation, I just don't know who's going to exploit it. It's the second time I'm putting my genome out. Nobody's downloaded it. I wish people exploit my genome, but they don't. So all the biologists and bioinformaticians here, please do exploit my genome and get back to me. So none of this fear in any...
But certainly there is exploitation, right?
No, but none of this fear in any other area of medicine have come true. I mean, blood testing is done only routinely. Nobody exploits them. People don't go and scam your blood test and try to know you better. And this fear has been there all the time for every progress that we did in humanity. If we discover something, bad actors are going to be there. And I do think they're going to be bad actors. For example, you can reflect on the China example of the 2 kids that were mutated. I don't know if you see the report, but they cured of HIV. The consequences.
Well, no. They didn't have HIV. They were trying to create an enhancement that would create a future protection for HIV should they be exposed, which is why there was no medical necessity, which is why I think it was.
Yeah, and so the question becomes more, what framework? Is that a framework that's universal and that's so is that a framework that's very Western? Like it's American people saying Chinese guys shouldn't do that.
Right.
And I'm not saying that because you're American, but what is the framework we're using? The world is a very complex place, and if you're from the West, you don't really understand the East and their origin and the philosophy really well and their approach to progress and etc. So what framework are we using? Are we all equal or not?
Okay, Sarah, go ahead.
Look, I want to build on that. I think you've got a great point there about, the global pattern of not just, who has power in science, but who has power in ethics. So, when this experiment was announced 6 years ago that a scientist had created genome-edited children, I agree, it was far too early, it's still too early, we need a lot more testing of safety, efficacy, etc. But you know what, all the press and all the scientists were like, oh, well, of course it would happen in China. This kind of attitude of ethical imperialism that, in the West we have good ethics and governance, but in the East, it's been described as the Wild East. And I think that's a really...
But it did happen in China.
Yes, but the idea that, well, of course it would happen there and not elsewhere. Scientific misconduct happens all over the world. There was the case of, the Swedish scientist doing the stem cell experiments, and nobody said, of course it would happen in Sweden. He was the individual bad guy, but Sweden has good ethics. So I think, this idea that certain countries have the power to say this is good ethics, this is not. I don't think anyone thought that was good ethics, but to say, of course, China has no ethics, I think is quite
let me jump in. It just so happens, you mentioned my recent book that came out this year was Super Convergence, but my last book is Hacking Darwin. And so in November of 2018, when there was the announcement made in Hong Kong by He Zhonghui that the first 2 at that time Chinese CRISPR babies had already been born, I called my publisher, because the book, it was already in process. It was already starting to be printed. And I said, I have bad news and good news. And the bad news is we have to take the book out of production because the book is about the future of human genetic engineering, and the world's first genome-edited babies have already been born, and I can't have a book that comes out after that doesn't mention it. The good news is that in the book, I say that this is going to happen soon. It's going to happen in China for this set of reasons, and I clearly articulated what those reasons are. And I said, and when it happens, I think it's going to be a mutation of one of these 5 genes, and I had a list, and CCR5, which is the gene that was mutated, was one of those genes. Since then, actually, from the last time I was in Doha, I've been one of the leaders of international efforts to determine the origins of COVID, which I believe most likely stems from a research-related accident in Wuhan, followed by a cover-up. And both of those stories are not stories that could only happen in China, but the structure, the norms, the absence of some of those safeguards increased the odds that they would happen in China. But I completely agree with you if the pandemic has taught us anything, it's that we're all connected, and that none of us has the highest standards. None of us should be doing any kind of imperialism in any scenario. And so the question is, for all of us, is how do we get better in all of these different areas? How do we get better within our societies? How do we learn lessons through sharing of best practices? You mentioned UK and human fertilization and embryology and the Warnock Commission, which is, I think, the gold standard of how to do these things. How do we share best practices internationally and even globally? And just one case now, as we went through this horrible experience of the pandemic, as we speak, the new pandemic treaty is being negotiated. The best case scenario, the greatest treaty that we can possibly imagine that would come out of this process, had that been in place in 2019, would have done nothing to prevent COVID-19. And so I think that's the issue, is these technologies are racing forward. How do we make sure that the human infrastructures can also become
So let me
stronger?
ask you this then, specifically about technology. How is artificial intelligence impacting precision medicine and genomics? Sarah, we'll start with you.
So I think artificial intelligence is a very broad term, ranging from
How would you describe it in this
well,
this field?
precision medicine and genomics already relies on this analysis of huge amounts of data, its algorithmic predictions. AI is, in one sense, essential to the precision medicine project. But then if you're thinking about AI as, Skynet or the computer from a space odyssey, that's so far off, that has no bearing. And then we have these sort of in-between, things that almost masquerade as personified intelligences, Alexa, Aria, all of these. ChatGPT is kind of an example. And I think the danger is that we're going to confuse something that's purely algorithmic with something that has that, what you call wide, broad, general artificial intelligence that has that bigger analytical picture. And we're going to take what these narrow AIs say as a reflection of something with wider analytical capacity. And that's where, when I'm saying ChatGPT is often wrong, because all it does is just predict what comes one thing after another. We're going to need both the algorithmic capacity to just process these vast amounts of data, but we're also going to need the kind of intelligence that currently still only humans have to analyze that and to say in the bigger picture, let alone the ethical intelligence to decide what should be.
I completely agree with that. I mean, basically the issue is human biology is so incredibly complex. If I were to say that if we understood everything about human biology, that would be 100, and if we understood nothing, we would be at 0. And if I were to ask people in this audience, where are we? If it were up to me, I would say maybe we're at 3%. I think we understand 3% of the total complexity of human biology and less of the entirety of all of biology. So we're talking about these very complex systems, and we know a lot more than our ancestors did, but still relatively little. But our ability, the ability of our brains to process these very complex systems is just way beyond us. So none of us, Albert Einstein, nobody on their own could just sit with a printed out genomes of A, C's, T's, and G's and just read it out and say, oh my God, this guy is going to win the Fields Medal, woman probably. And so there's a really high level of complexity, and I agree with what Sarah said. I don't even like to use, I like the letters AI, but artificial intelligence just makes no sense to me. It's like we're not creating fake humans, we're just creating, I think, machine intelligence. Maybe it'll be machine super intelligence. It's its own thing with its own set of capabilities. And so I think it's just completely wrong and frankly dangerous for humans to say, oh, these AI systems are going to be so smart, they're going to do everything better than we do, which I think the whole idea of AGI is total nonsense, at least my humble view. But we're going to have to figure out what humans do best and what machines do best, and the name of the game is how do we stitch those systems together that allow us to be not second-rate humans, but to be first-rate humans doing the maximal contributive human things.
Do you agree, Arash?
So I agree with the 3%. I would say a little bit more, and I think one of the reasons is the structural approach or conceptual approach we have, which is everybody here works on a single protein and tries to build a biological model to answer, oh, that my protein increases this. So they kind of like torture the data or torture the model, and I think that's a very bad approach to system biology, and there's very little system biology. I see more artificial intelligence as a skill transfer tool. So the progress are going to be amazing. I have like friends that are really involved at high stage of the forefront of AI with like Glock or ChatGPT companies, and what they describe to me and the level of computational that goes right now for the next model is so high that our brain cannot comprehend it. But look at Midjourney, which is a generating image. What Midjourney did, beside the intelligence behind it, is that it made everybody in that room a designer. Most of them average designers, some of them amazing designers. I've seen some work by Midjourney that cannot be done by a photographer. But we became designers. And I can now go and sit on my computer and design something, which a skill I didn't have. So everybody here is going to become a geneticist. That's going to be the skill that transferred to the people, is their own personal ability to analyze yourself and ask questions yourself.
But I got to ask you, isn't that hugely risky?
It's not hugely risky. People, they can interpret their blood tests. Right now, you can go and take your blood test, upload it to ChatGPT, and ask a question. I tried it all the time. In France, actually, we organized a competition at our last meeting between senior geneticists and ChatGPT, and the senior geneticists failed.
I think Sarah will have something to say about ChatGPT.
No, they failed. Yeah. They failed. I mean, in a competition of a clinical case against ChatGPT and Gemini, the most senior geneticists of France failed. So that would mean that if I have a genetic disease, I want first ChatGPT. So
Sarah, I know you want to say something.
But
I think you're right for narrow questions. You're right. It's that narrow versus general issue that we've been discussing.
Yeah, so the question is not, do I want ChatGPT or do I want an augmented doctor? And so yourself now can be somehow your augmented doctor. And our mission becomes to educate people and not prevent them. Like, prevention doesn't work. It's going to leak. It's going to be there. You cannot say people should not generate images. They're going to generate images. They're going to have hacks. Most of computers of the new generation can run an LLM model on themselves. So you don't even need a company. In a few months, you will be having your own LLM on your computer, and they will know everything about you. We've seen with at a party in France, we've seen one of these nerds from San Francisco. They created this interface that looks at everything you're doing on your screen and records it, and then suggests you stuff. So if you're a designer, it tells you, oh, every time you start designing, you start by doing these 5 layers. Do you want me to do it for you? So it predicts what you're going to do. So we're already there. I don't think it can be stopped. You cannot prevent that.
Yeah, Jamie, go ahead.
Yeah, so I'm just agreeing with Sarah's short comment. The question, it's the details. Yesterday we had Robert Greene spoke to us, and he talked about bringing together, I think it was 200 different genetics experts, and they went through and they said, all right, right now people get the heel prick blood tests for newborns, and over time, medical professionals and others have said, well, what are the tests that are most indicative? And now anybody born really anywhere in the world gets these tests, because we know there's a correlation between the indicator and a potential problem. So we're going to get more and more of those kinds of things, which will be clear enough that we can trust them. So just like dermatology is one case. There are beginning to be these applications where if you have some kind of growth, you can take a picture of your growth, and the AI system can do that radiology. And I think that will just get better and better. And so we'll get to the point where these kinds of AI-driven treatments are great, and we will see rapid decentralization, and that'll be fantastic because most people, or many people in the world, billions of people, don't have access to even minimal standards of healthcare, and that's great. As we move up the complexity ladder, as Sarah referenced, I think there will be a danger of some AI system giving people information that the AI system itself doesn't know, because we don't understand these complex systems. And I just think that that's why education and governance and regulation, because I think we probably all know people who get some kind of half-baked piece of information and start changing their whole lives based on that. And that's why we have structures in our societies that are designed to protect us.
Okay, well, we've now come to our majlis. So that's an opportunity for reflection and truth-seeking. I want to return to the intention outlined in the introduction, and that's to contribute to our collective wisdom and to help steer humanity towards a future where these technologies are used for the greater good. So what areas from today's discussion should we focus on to ensure that precision medicine and genomics lead to a fairer world? Sarah, I'll start with you because you focus quite strongly on ethical dilemmas and you offer insights into the motivations and methods of the scientific and research community. So where do you see areas of agreement?
I want to draw out this notion at this time to reflect, I want to draw out this notion of the greater good and ask, what do we understand to be the good? And, we've talked a lot about values and, sometimes hidden, sometimes explicit values. I want to give you all something to reflect on and to throw an idea out there. I'm going to say, health is not in itself valuable. Right? Health is not intrinsically valuable. Health is just biology. It's just an accident of the way the world is. Health is instrumentally valuable to us as human persons because if we don't have good health, it stops us from achieving all the things we want to do, pursuing our own conceptions of the good life. And I think, although Jamie, you've said a few times these technologies don't have any values built in, I do think that healthism is a little bit built in, the idea that, well, health is a good we should be pursuing. And most of the time, as I say, you need health because you need to be healthy to be able to do what you want to do. But, there's a joke, right, where they say, if you want to live a long life, give up drinking, give up partying, give up risky sports. Your life won't be any longer, but it will feel long. And I think when we start thinking that health is itself the greater good, rather than that human flourishing is the good towards which health can conduce, we might lose sight of what's actually valuable. So what is the good life? It starts with health, but it's not only health.
That's a great point.
Yeah, Jamie.
So I would say I'm kind of a healthist and a humanist.
No, but what you are is you offer a futuristic perspective,
yes.
right? And you talk about the importance of connection and collaboration. Yeah. So where do you see points of commonality?
So in my new book, Super Convergence, at the end of the book, I have a pyramid where I talk about what's it going to take to realize our best potential, not just in healthcare, but more broadly, but it equally applies to healthcare. And at the base of that pyramid is individual education, engagement, and empowerment. The individual is the foundation. But as we kind of move up that ladder, we need, it's the same governance point, at every point, whether it's communities, faith communities, companies, countries, internationally and globally. So we really need to think at every level, not just how do we think more and try to build the kind of systems around health, but how do we build the kind of systems for accountability? How do we tip the odds in favor of human flourishing? And so there's a connection between what we're doing now, educating ourselves and each other, and really thinking about even as big as global superstructure reform. I'm a founder of a global interdependence movement called One Shared World, which we created in the early days of the pandemic, out of this feeling that there's a mismatch between the nature of the greatest problems that we face, which are global and common, and the absence of a framework to address that entire category of challenges. That is a choice that we humans have made. We're here in a nation state. The modern idea of a nation state, it's not something from time immemorial. This was really encapsulated in the Peace of Westphalia in the 17th century. The idea of the United Nations and this international institutions that went through 150 years of trial and error, and then the UN was created to create this new superstructure. And now we live in a world where the UN system is largely failing. If we want to have a world where we can all come together to solve these kinds of problems, that is a human aspiration. And I don't know whether we can do it or not do it, but articulating what we are trying to achieve and articulating for ourselves what does it mean to flourish, using Sarah's word, on every level. And those, I think, that needs to be our marching orders.
Okay, Arash, you've said, we heard you earlier saying that access to one's genome should be considered a fundamental human right, not just to prevent disease, but to enable everyone to live their fullest, most informed lives. Where do you see common ground going forward?
I think that what happens with the development of technology is more autonomy. I can do more stuff myself. I don't have to rely to a layer of, the people that know and I don't know. So now, basically, if you have any knowledge about your medical file, you can upload that on ChatGPT or any AI, and you get the treatment plan the same way a doctor would give you that. And as a doctor, as a practitioner, I use it every day for my patient. I interrogate AI. It removes time from me to do the technicality of it, and I have more time to put my hands on their shoulder. So I have more time to focus on the human relationship. And what I learned is that you should trust humans. You should trust humans. Very few of them would do bad things, because the China event, which is whether it's China or not, happened only once. It didn't happen at scale. And there's many countries with, I would say, the same ethical framework that China. It happened only once in China, and it's not a bunch of mad scientists doing that. So most humans would do good. And so I would start from a place where we ask people what they want. You come to CIDRA, you have, do you want your genome? Yes or no? And then some people will say no, and then you understand why they don't say no. What are they afraid of? And the other one that say yes, then give them the info and give them the tools to analyze it. So I think what's going to happen within the next 5 to 10 years is more autonomy. I hope that next year at the same meeting, everybody will raise their hand when we ask if you have your genomic information, and not only me, and or 5 people, And so I think that the future, we should really trust human beings. I mean, there's some bad stuff happening in the world,
right.
But most historians would agree that there's never been better time. Life expectancy is on the rise, education is better, etc. There's still pockets of darkness, but they're going to probably fail surviving on a long term.
Okay. We'll leave it there on that note. Thank you so much. I'd like to thank our guests, Sarah Chan, Arash Rafii, Jamie Metzl. We appreciate your time with us today. Thank you. And thank you to Qatar Foundation for bringing us all together, and to our partner, CIDRA Medicine. We can continue the conversation online on Instagram, YouTube, and Twitter. We're at Doha Debates on all social media platforms. Thanks for being here today, and bye for now.